Hello Year 5 and welcome to your maths lesson. So today we're going to be looking at comparing and ordering fractions that are less than 1. So we're going to be looking at fractions that have different denominators and different numerators, and we're going to learn some different skills of how we can order them without having to change the numbers. But what we're going to do first is we're going to warm those brains up of yours. So put a 5-minute timer on, time yourself, have a go at doing these questions. Okay, so Dan earns £2,072 per month. How much does he earn in a year? Well, we know there's 12 months in a year, so we've got to multiply that by 12. And the answer is £24,864. Multiply 172 by 5, should be easy peasy. Your multiplication is 860. Which of these numbers has a remainder when you divide by 5? Now, you should know that anything that has a remainder divided by 5 must be a number that doesn't end in 5 or 0. And I can see, looking at these numbers, that 35, 45 and 80 are multiples of 5 and 77's not. That means that 77 is going to be the one with the remainder. Work out 5,512, subtract 3,272. Your answer is 2,240. Now, if you had a go at doing the time on the clock, I can see that the clock says that it is 6:58. Okay, if you're going to do that in 64-hour clock, it would be 1868. Okay, so effectively 2 minutes to 7. Okay, well done if you got those all correct. If you made a mistake somewhere, just go back and check your answer and work out what it was you did wrong and get the correct answer. So that was your warm-up for your multiplication, which we looked at last term, or for our last topic rather. Now we're going to do some quick warm-up ones to do with our topic this week. So pause the video, give yourself 5 minutes, have a go at these questions. Okay, complete the equivalent fraction. Well, we know whatever we do to the denominator, we do to the... Good, we do to the numerator. So how do we get from 5 to 20? Multiplied by 4. Therefore, 2 multiplied by 4 is going to give us 8. Okay, write the first 7 multiples of 7. Okay, easy. 7, 14, 21, 28 and 35, 42 and 49. I'm not singing the rest because now it just looks stupid. Write the first 7 multiples of 4. So this is your 4 times tables. 4, 8, 12, 16, 20. That's how we roll our 4s. 24, 28, 32, 36, 40, 44, 48. Okay. What is the lowest common multiple of 4 and 7? So looking for the first number that comes up in both times tables, that's the smallest. Well, if we count along here, we've got 7, 14, 21. We've got 4, 8, 12, 16, 20. So far, no common multiples. 28, then 20. Okay, so I can see that 28 here is the next lowest common multiple. Okay, so it's the same multiple for both of them and it's the lowest one. Okay, so well done if you got those all correct. Okay, now you've had a good laugh at me singing today as well. Lucky you. So we're going to look at ordering fractions. Okay, so we need to write down, using our inequalities, which one of these fractions is the biggest or the smallest. Okay, now we can see that our denominators are the same, so we just need to be looking at our numerators. We can clearly see that 7/10 is bigger than 3/10. Okay, we set it out using bar, got 3 out of 10 and 7 out of 10. We can clearly see that one's the biggest one. Therefore, that 3/10 is actually smaller than 7/10. Okay, now that's nice and easy when your denominators are the same. So the rule we have when their denominators are the same, that the greater the numerator, the greater the fraction. Okay, so the bigger this number on top is, okay, the greater the fraction is, the more of that pizza that you've got. So if I had a pizza and I gave Damari 3 pieces, but then I decided to give Keaton 7 pieces, Keaton's got more than Damari. Okay, because of between the 2 pizzas that both have 10 pieces, Keaton's been given more, so it's the greatest. Okay, equally, when the denominators are the same, the smaller the numerator, the smaller the fraction. So here's Damari's pizza. He's only got 3 parts of that pizza, whereas Keaton had 7. Okay, so that also makes it smaller if the numerator is the smallest one as well. So, well, let's think, well, how do we write and compare these fractions? Because the denominator is not the same, and nor is the numerator. But if I go back to my rules, when the denominators are the same, okay, we know the smaller the numerator, the smaller the fraction, okay? So I need to find some multiples that I can think of where I can now convert these fractions so that the denominators are the same. Well, I can see they both appear in the 5 times table. So my multiples of 5 is 5, 10, 15. Well, see, that one's got 15, which means I can change this one to 15 as well. So if we converted this now, we have to think, going back to our rules last week, whatever I do to the denominator, good, you do to the numerator. So to get from 5 to 15 is multiplied by 3. So we're going to multiply the numerator by 3. That's going to give us 6/15. Now, if I then go back and compare that to my original fraction, 6/15 is smaller. Therefore, 2/5 is actually smaller than 7/15. Okay, so all we did there is we converted this fraction so that our denominators were the same. So pause the video and see if you can have a go at working out these ones. And I'll give you a clue. Look at the numerators. Think about, well, the denominators. Think, how do I make the denominators the same? Whatever I do to the denominator, I do to the numerators. Pause the video and have a go. Okay, well, 1/6, okay, I can convert to 3/18. Okay, because 6 goes into 18 3 times, so I'll multiply my numerator by 3, so that gives me 3/18. I can clearly see here that 5/18 is bigger, which means that 5/18 is bigger than 1/6. Here I can see a common multiple of 5. I know that 5 times 5 is 25, so 5 times 3 there is going to be 15 over 25. And I can actually see that 15 over 25 is larger than 12 out of 25. So that makes 3/5 bigger than 12/5. Now this one's an easy one. I don't need to change these denominators. Why do I not need to change these denominators? Okay, because it's a whole fraction. That is equal to 1. If I had 36 chocolate bars in a pack, and I've got all 36 of them, I've got a whole pack. If I had 9 chocolate bars in my pack and I had all 9 of them, I've still only got one whole pack. So these two are actually the same because they're both representing whole fractions. So well done if you got those ones correct. Now this is where it starts to get a little bit tricky. Okay, so bear with. Now Dexter here says that he knows that 4/7 is greater than 5/11 without actually having to draw a bar model or finding a common denominator. So I want to pause the video and have a think. How on earth could he possibly know that 4/7 is greater than 5/11 without doing anything? Okay, well what he's actually done is he's used his knowledge of a half. Okay, so he's applied his knowledge of a half to both of these fractions. Now I know that sounds complicated, but let me talk you through it. Okay, so if we are finding the half of something, we know that that middle line there means a divide. So if I'm finding a half of something, my denominator is 2. That means I'm going to divide by 2. So if I did my denominator 7 divided by 2, that's going to give me 3.5. Now my numerator is bigger than 3.5, so that's more than a half, that fraction. So that tells me that 4/7 is greater than 1/2, because 1/2 is only 3.5. If I have a look at this one here, I'm going to do 11, because that's my denominator, that's my whole equal number of parts. And let's divide that by 2 as well. Well, that gives me 5.5. So my fraction would be 5.5 over 11. Now, obviously, I can't have a decimal for it, but even if I was to have it as a fraction, half is 5.5. My numerator here is only 5, which is actually smaller. So that means that 5/11 is smaller than a half. So without changing my denominators, Dexter's worked out what half of both those numbers would be, which would be 3.5 and 5.5. And can see here that this number's bigger than the half, and this one's actually smaller. Okay, so that actually means that 4/7 is greater than 5/11. So using that same concept, I want you to pause the video, use your concept of what you know as half of numbers, see if you can work out what the missing inequality is here. Okay, well, again, we're going to take our denominators and divide it by 2, because the denominator for a half is 2. We know that line means to divide. So 14 divided by 2 is 7. So half of 14 would give me 7, and I can see I've got 8. So this is bigger than a half. If I then did 22 divided by 2, that gives me 11. However, that means that's half. Well, 10 is actually smaller than 11. So that means that that number there is actually smaller than half that number. Okay, so as a result, that must mean that 8/14 is actually bigger than 10/22 because it's more than a half, and this number was actually less than a half. Okay, now this one makes it a little bit trickier because this time round, my numerators are the same. So if I draw these out, so I've got 4/9 then, I've got 4/5. And here I've got 2/3 and I have 2/7. I want to pause the video and have a think. What's the same? And what's different? And do you notice anything about our fractions? Okay, well, I might have slightly given it away to the beginning. Well, here we can see our numerators are the same, but actually this time round we have our denominators that are different. Okay, now looking at my bar model, I can easily see that 4/5 is bigger than 4/9. And here I can see that 2/3 is actually bigger than 2/7. Okay. So now we need to think, well, when it was the denominators, we know that the greater the denominator, the larger the fraction. But this time round, when we know the numerators are the same, the greater the denominator, the smaller that fraction is, okay? Equally, the other way around, the smaller the denominator, the greater the fraction. Now, let me explain that to you so that it makes more sense. So imagine these are my pizza. I have one whole pizza, or rather I have two whole pizzas. And I've cut one of my pizzas into thirds, okay, 3 equal parts. I've cut my other pizza into 100 equal pieces, okay? Now, my numerators are both the same, okay? So the bigger that denominator, okay, actually means the smaller the fraction. Okay, so if my denominator here is 100, that means I've split something 100 times, which means it's going to be really, really small. Whereas if I've split something 3 ways, I'm going to get a larger piece of each fraction. So if I imagine this is my pizza now, okay, yes, my numerator is the same, but that's a really big denominator. That means if I hand out 100 pieces of my pizza, everyone's going to probably get a handful of crumbs. But if I handed out my other pizza and I had 3 slices and I shared that with 3 other people or 2 other people, we're going to get a much bigger portion of that pizza. So it actually means the bigger that denominator, the more teeny tiny parts you've actually split that whole pizza into. Okay, so the smaller the denominator, okay, means actually it's a bigger fraction. Okay, you divide something by half, you're getting half a pizza. Okay, so that's 1/2 of a pizza. You get a third, you get a smaller piece. You get a quarter, you're going to get a quarter of the pizza. By the time we're starting to split it into 100 pieces, you're getting crumbs. You might even get like, a teeny tiny piece of pepperoni, a little nugget of cheese, and like a crumb from your crust. That's going to be 1/100th of the pizza. But 1/3 is going to be bigger. You'll get a bigger slice of it because it's shared into less parts. So the bigger the denominator, the more parts you've split it into, which means that everyone's going to get a smaller piece. The smaller that denominator means there's less pieces to be shared around, so everyone gets more, okay? So I know that sounds like a tricky thing to get your head around because technically the smaller the fraction, the bigger piece that you get. But if you imagine it like pizza, you split a pizza into thirds and a pizza into hundreds, okay, that person getting that 1/3 of a slice is getting a lot more than that one person that's getting 1/100th of a slice of a piece of pizza. Okay, so imagine it like pizza. The more pieces you split it into, the smaller slice you get when you take it. So let's see if you can have a go at ordering and comparing this one. Okay, so going back to our rule that we looked at, here we don't have a numerator that's the same or a denominator, but we can find our common multiples. Okay, so what 2 numbers, looking at these, can we convert that match the same times table? Good, well 3 and 6 do. I know I can get 3 into 6 2 times, okay? So I used to think to myself, well, if I turn 3 into 6, I've got to have multiplied it by 2, which means I've got to do the same thing to my denominator. So that's going to be 6 and 14. So now if I have that sum, I've got 6 over 14 and I've got 6 over 11. Now going back to my original rule, okay, when the numerators are the same, the bigger that denominator, the smaller that fraction. So that actually means that 6 over 14 is actually smaller, okay? Because if I've split my pizza into 14 pieces, I'm going to get more pizza if it's split into 11. It's going to be a bigger size piece of my pizza. So what I want you to do is I want you to pause the video and see if you can have a go at these ones. Okay, let's whiz through these answers. Okay, so here I can get my multiples of 3 into 12, multiply it by 4. So it would give me 12 over 40. 12 over 40 is going to be smaller, okay? Because remembering, if I'm splitting it into 37 pieces, I'm actually going to get a bigger slice. This one here, to get from 20, okay, I have to divide it by 2, okay? So I can actually make this smaller, or I could make this one bigger. And I can actually see that 10 over 27 is going to give me more slices because there's only 27 slices to choose from, whereas here it was 31. So actually I'm going to get a bigger piece of pizza with the smaller number. And here I've got 1 into 3, so I can think I'm going to multiply that by 3. That's going to give me 3 over 15. Now, if I have a pizza with 15 pieces and a pizza with 8 pieces, I'm getting a bigger slice if it's going to be only 8 pieces. Therefore, 3/8 is going to be bigger. So you just imagine your pizzas. Okay, you imagine, look at your denominators. I've got a pizza that's cut into 31 pieces and a pizza cut into 27. I'm going to get a bigger slice, okay, if it's cut into 27. Same as here, you've got a pizza cut into 15 slices and a pizza cut with only 8 slices. That's going to be a bigger slice each time, okay, because I've had to portion it less times than the bigger one. So have a go doing questions 1 to 4 on your worksheet. Go back and pause the video if you need to. We're going to pick up the second half of your worksheet in our next lesson tomorrow, okay? Good luck, year 5.